Hey guys, in our last trig lesson, we are going to talk about graphing tangent functions. So first off, let's talk about our parent function of the tangent of theta. So just like we talked about with sine and cosine, when we are plugging in for these x and y, x is really your theta and y is the tangent of theta. Tangent isn't something we can directly get from looking at our unit circle, but tangent is the same thing as sine of theta over cosine of theta. So we do get sine and cosine from our unit circle. If you don't have your unit circle out, I'd get it out so you can be looking at that. So as we are taking a look at graphing this one is going to be a little different than sine and cosine. So let's start at 0 here, and I'm going to see what happens at 0. So if I'm going to sketch this unit circle over here, if I'm over here at 0, my point is 1, 0. So this is cosine of theta, sine of theta. So that means I'm dividing y divided by x. So 0 divided by 1, 0 divided by anything is 0. Let's talk about what happens then at pi over 2. So pi over 2 is up here at the top. The point is 0, 1. So divide y by x. 1 divided by 0. We can't divide by 0. So that actually happens to be undefined. And so what we find out there then is if that's undefined, that's going to be an asymptote. We can go to 3 pi over 2. Then, and at 3 pi over 2, we're at -1, 0. Or sorry, that is not 3 pi over 2, that's pi. At pi, we're at -1, 0. So 0 divided by -1 is 0. And then at 3 pi over 2, we're at 0, -1. So again, at 3 pi over 2, we've hit undefined. So I'm going to plot what we have so far. I'm actually going to go pi over 2, pi, 3 pi over 2. I could keep that going as well if I wanted to. So pi over 2, we said we're undefined. There's an asymptote there. At 3 pi over 2, we have another asymptote. If I went back to -pi over 2, that same thing would happen. At 0, I'm at 0. At pi, I'm at 0. So you'll notice we don't have a lot going for us on this graph yet. So I want to see what's happening at those points right in between. And so that's what that's why I've left these spots in here. So right in between pi over 2 is 0 and pi over 2 is pi over 4. Right in between pi over 2 and pi is 3 pi over 4. We can look at -pi over 4 here. We can look at 5 pi over 4. We can look at 7 pi over 4 if we want to. Okay, so at pi over 4, that's right here. That's my 45-degree angle. I have radical 2 over 2. radical 2 over 2. Well, that doesn't look very nice, but actually when you're dividing the same thing on the top and the bottom, that goes to 1. So pi over 4 is just 1. So pi over 4, I'm up at 1. If I look at negative pi over 4, that just means I'm going the other direction. So I'm down here, so I'm still at a positive radical 2 over 2, but negative radical 2 over 2 for y. So when I divide that, negative pi over 4 gives me negative 1. All right, that's showing us a little bit more. So what I will tell you then is your graph is going to look like this for a tangent. So it's approaching infinity at those asymptotes, and it's going to keep doing the same thing. So if you found out 3 pi over 4, you would get negative 1 again. 5 pi over 4 would take us back to 1. So it goes like this again. So then one period is actually going from negative pi over 2 to positive pi over 2, from asymptote to asymptote. And so our period then is pi, because going from negative pi over 2 to pi over 2 is pi. From pi over 2 to 3 pi over 2 is 1 pi. Now, our range is going to go on forever and ever. That will go up and down in both directions to infinity. So negative infinity to infinity. Domain is a little bit challenging here. Domain is all real numbers except x cannot equal where it's undefined. And so it is undefined at pi over 2. And then at every additional pi after that. So at pi over 2, if I add another pi on, I'm at 3 pi over 2. And then if I add another pi onto that, I'm at 5 pi over 2. And another pi would be 7 pi over 2. So I'm going to add plus every pi times some constant value. And I'm just going to use k there for some constant value. So x cannot equal any of those values. So then that also happens to be where our asymptotes are. So x equals pi over 2 plus pi times that constant. All right, let's look at what happens when we change the values of the period and the asymptote. So the period just happens to be pi over b. So just like with sine and cosine, it was 2 pi over that b value. Since our period here for tangent is pi, it's pi over b. Asymptotes are going to be odd multiples of pi over 2 times the absolute value of b. And so we'll look at what that means when we get to graphing one of these. So odd multiples of pi over 2 times the absolute value of b. So here we have 3 tangent of 4x. So our period is pi over b, which is 4. And then our asymptote is x equals, we said it's going to be odd multiples of pi over 2 times b. So our b value is 4. So pi over 8, 2 times 4 is 8. That's where our first asymptote falls, plus our period, times our constant. All right, so if I start to graph this, then I know that at pi over 8, I have an asymptote. That means I also have an asymptote at negative pi over 8. At those values in between, the number in front of the tangent tells me how high and low to go on the graph. So I'm at 3 and negative 3. So the values right in between 0 and pi over 8 are pi over 16 and negative pi over 16. So at pi over 16, I'm up at 3. At negative pi over 16, I'm down at negative 3. At 0, I'm at 0. So I can keep counting by pi over 16 here. So 1 pi over 16, 2 pi over 16 is pi over 8, 3 pi over 16, 4 pi over 16 is pi over 4. Then we have 5 pi over 16. Then 6 pi over 16 is the same as 3 pi over 8. And that happens to be another asymptote. So at pi over 4, I'm at 0. At 3 pi over 16, I'm at negative 3. At 5 pi over 16, I'm at 3. You can make an XY chart plotting those points as well. That is all I have for you today. So if you have any questions, you can come in and see me over these tangent graphs. Otherwise, I will see you in class.